Hey folks, Jeff here. Today we're going to be talking about high availability in a data center environment. I decided to make this video after a meeting with a customer of mine. My customer gave me the following scenario. I have two locations in the Chicago area, about 20 miles apart. I want to do a high availability solution with Palo Alto Networks firewalls. This is pretty common for businesses around Chicago, where they may have some resources in a data center in the city and other resources in a secondary data center in a Chicago suburb. Question 1. Can I do an active-passive or active-active configuration with one firewall in each location? To answer this, we'll talk a bit about what it takes to do HA for our data center firewalls. I'll focus on the 5200 series platform, as that's the most likely choice for a data center. The other models may differ a bit, but the general concepts will remain the same. Question 2. Assuming we can do HA, what is the acceptable latency for communication between firewalls in an HA pair? As with anything communicating over distance, latency becomes just as important as throughput, so we'll discuss that as well. Let's run through this. We should be able to answer these questions in less than 10 minutes and make you smarter about high availability by the time we're done. Let's start with high availability concepts so you can understand our options. On every Palo Alto Networks firewall, we use three types of HA interfaces: HA1, HA2, and HA3. Each one has a specific purpose and a way that it communicates, so let's discuss them. The HA1 interface is the most important. HA1 is used to exchange heartbeats, hellos, management sync, routing, and user ID information. On the 5200 platform, there are two HA1 ports, HA1A and HA1B. These are each layer 3 interfaces with separate IP addressing for each interface. They are copper 10-100-1000 ports. Since the heartbeats and hellos use this path, the HA1 interface must be redundant. If you lose this connection, the firewalls will go split brain, meaning both firewalls in the HA pair will believe the other firewall is gone and will operate as the primary firewall. As you can imagine, two firewalls with the same configuration and addressing operating as the primary will create problems. The next one is the HA2 interface. The HA2 interface is responsible for synchronizing information from the primary to secondary firewall. The HA2 interface will synchronize sessions, forwarding tables, IPsec security associations, and ARP tables. The data flow on HA2 is unidirectional, aside from keep-alives that will flow in both directions. Data will flow from the active to passive firewall or primary to secondary in an active-to-active configuration. On the data center models, the 5200 and 7000 series use an HSCI port. HSCI stands for High Speed Chassis Interconnect and uses either a QSFP Plus or QSFP28 optic for a 40 or 100 gigabit connection. Finally, we have the HA3 interface. The HA3 interface uses the same high-speed chassis interconnect link that we use for HA2. This interface is the packet forwarding link and is only used in active-active configurations. The primary purpose is to move production traffic between firewalls when traffic is asymmetric. For example, traffic goes from a user out to the internet through Firewall A. The return traffic comes in through Firewall B. Firewall B will use the HA3 link to send the return traffic to Firewall A so that Firewall A has a complete session. The HA3 link is a layer 1 interface. As you can see, it doesn't support layer 3 IP addressing or encryption. Since we do encapsulation, MTU can become an issue here. The firewall will automatically configure the MTU on the HA3 interface correctly, but if you send other non-IP traffic across this link, we can run into fragmentation across the link. I've seen a number of customers enable jumbo frames to keep traffic from fragmenting across this link. One final piece to understand before we try to answer the first customer question is the optics for high-speed chassis interconnect. Normally, when the firewalls are in the same data center, we'll recommend the first option, the AOC cable. This is the optical cable with transceivers attached and installs as a single piece. It's 10 meters long, so it's normally not an issue to reach from one firewall to the other. Since we're talking about going longer distances, let's look at the other options. The 40 gig SR4 optics are what we'd put in for a multi-mode fiber connection up to 100 meters. The big caveat here is that the connector type may be different than what you're used to. Palo Alto Networks uses IMPO connectors and connect to a 12-strand fiber infrastructure. This will not work for many customers who are expecting an LC connector and the use of their existing fiber plan. The options to resolve this are either run cable directly for the distance needed or install IMPO-compatible fiber and patch panels. To go longer distances, you'll switch over to single-mode fiber. There are two options here, the LR4 and ER4 optics. LR4 will go up to 10 kilometers and ER4 will go 40 kilometers. With our understanding of high availability interfaces, let's go back to the first customer question. Can I do high availability across long distances? Remember, the HA1A and HA1B interfaces are copper, which may be an issue since you'd need to convert media or go through a switching environment to go over distances, but at least it's layer 3. The high-speed chassis interconnect interface is a layer 1 interface for both HA2 and HA3, so this can be an issue over large distances if you're not using dedicated fiber between sites. So if the default HA ports won't work for us, is there a way that we can use the data plane ports to go over long distances? The answer is yes, there is a way to use the data plane ports for HA, but you'll have some trade-offs. You can designate network interfaces from the data plane to be used as HA2 and HA3 ports and configure them as layer 2 or layer 3 interfaces. This means that you'd be able to do HA over a switched or routed environment. On the HA3 port only, you can combine multiple 10 gig ports into an aggregate Ethernet interface. This option isn't available for HA2, but you're not sending much data on HA2, so it's really not an issue. Here's the trade-off. If you use the default HA ports that are part of the management plane, they don't take away from the total throughput of the firewall and are not impacted by data plane issues. If you start using data plane ports for HA, any data going across will take away from the total throughput of the firewall, and the HA ports are now susceptible if you have a data plane failure. One final note on this question. If you're going to be doing active-active high availability over longer distances, you'll potentially have a lot of data traveling over the HA3 interface. How you designate which firewall does the session setup and which is the session owner of that traffic can have a big impact on performance. For example, if the first firewall is receiving the traffic and sending it out, but the second firewall in the pair does the session setup and is the session owner for that session, there will be a lot of unnecessary data traversing the HA3 link. There are 4 types of load sharing algorithms that can be used, and you can designate a different one for session setup and session ownership. IP modulo is the default method and is essentially a round-robin method and based on source IP. IP hash is similar to IP modulo, but instead uses a hash of the source and destination IP. Primary device means that whichever firewall is the primary firewall in the active-active configuration will control that session. And first packet, whichever device receives the first packet of the session will own or set up that session. Palo Alto Networks recommended settings are to set session owner to first packet and session setup to IP modulo. But depending on your architecture, you'll want to select load sharing options that limit the amount of traffic that has to traverse the HA3 link. Now that we've answered question 1 and helped you understand what you need to consider when implementing high availability in the data center, let's focus on question 2 and talk about acceptable latency for communication between firewalls in an HA pair. I haven't seen any official document from Palo Alto Networks, but the unofficial guidance provided to technical and sales engineers is that latency between the primary and secondary firewall in an HA pair should be kept at 20 milliseconds or less. Having said that, I've heard reports from some systems engineers claiming to have customers running HA environments with 90 to 100 milliseconds of latency without issue. But let me be clear, I do not recommend this architecture and would actively discourage my customers from implementing something like this. In conclusion, I'm going to advise my customer that the latency between the two locations shouldn't be an issue, and if they can use dark fiber for the HA2 and HA3 connections or use data plane ports, they can physically make this architecture work. We'll have to consider the rest of the architecture to determine the load sharing methods to be used, and we'll need to understand traffic flow to tune the configuration appropriately. Thanks for joining me today to understand data center high availability using Palo Alto Networks firewalls. If you have any questions or comments, please post them below, and as always, stay secure.